Maths educational video. We're going to learn two important quantities in vector fields. They are known as curl and divergence. We'll focus on the definition and the computation of these quantities. In more advanced courses, you get to learn their applications. So first, the curl vector. Given a vector field F with component functions PQR, the curl of F, which is itself a vector field, is given by this rather complicated formula involving the partial derivatives of PQR. Interestingly, this expression can be obtained by taking a cross product of two vectors. The first vector is what is known as the del operator. The second one will be the vector field F itself. I leave this to you as an exercise. If you perform this cross product faithfully, you can recover this formula. Because of this interesting fact, we can sometimes write curl of F as del times F. Let's look at a specific example. To complete the curl of F, we simply identify PQR and perform the first order partial derivatives according to the formula. After some simplification, you will get the resulting vector field, which is the curl of F that we want. Another important quantity for vector fields is what is known as the divergence of F. And the divergence is a scalar, not a vector. What you do is to take the first order partial derivative of PQR with respect to x, y, z respectively and sum up these three derivatives. That we call the divergence. Just like the curl of F, the divergence can be written as a vector product, but in this case, it's a scalar or dot product. We can verify this easily. We end the video with a theoretical exercise. This result is very important. The divergence of the curl of F is always 0. And here is a jargon to learn. Any vector field whose divergence is 0 is called incompressible. So what I'm trying to prove here is the curl of F is incompressible. Obviously, our strategy is to first compute curl of F, after which we will take the divergence of this vector field. For the curl of F, we write down the formula in terms of the component functions PQR. Let's call the new component functions ABC. Then we apply the definition of divergence to the curl of F to get dA dx plus dB dy plus dC dz. And now all we have to do is to differentiate ABC with respect to x, y, and z respectively. We end up with 6 terms, and our job is to show that the outcome is 0. So obviously we'll group them into like terms. P with P, Q with Q, and R with R in different colors. Let's focus on one of them, say the one in blue. We have Ryx minus Rxy. And we recall the mixed derivative theorem, which says that Ryx and Rxy are equal. And because of the minus sign, we get 0 for the blue terms. And the same applies to the green terms and the red ones. So as expected, the outcome is 0. And we are done.